question. So here you have AB, CD, PQ are perpendicular to BD. If AB equal to X, CD equal to Y, PQ equals to Z, prove that 1 by X plus 1 by Y equals to 1 by Z. Here they asked to prove what? 1 by X plus 1 by Y equals to 1 by Z. Now here you have a perpendicular to BD where AB, CD and PQ are perpendicular to the side BD. Now let's solve the question. So let's first write down the given data. So the given data is what? Given data is where angle B equals to angle Q equals to angle D equals to 90 degrees. Right? So where angle B is 90 degree, angle Q is 90 degree and angle D is also 90 degree 90 degree angle where we have. Now next, as here if you observe the given figure where AB is parallel to PQ, PQ is parallel to CD, AB parallel to PQ, parallel to CD. Where PQ is parallel to CD. Now next here, to prove this, firstly we have 1 by X plus 1 by Y equals to 1 by Z. So to prove this, I would like to take, firstly let's take the triangle ADC. Okay. Now consider triangle in triangle BDC. In triangle BDC, where and triangle BQ. Now consider these both triangles, triangle BDC and triangle BQP. Okay, just consider these both triangles. So by these both triangles BDC and triangle BQP, we must firstly prove that these both triangles are similar, where BDC is similar to BQP. So to prove similarity between them, first let me draw this triangle separately over here. Like let me draw firstly triangle BDC, where we get like triangle B over here, BDC, right? D, C, B, P and Q, right? BD by B. Okay, done with this. So here we got a triangle where BDC, where BQ and BD over here, and we get like here. Okay. So here we got what? Two triangles in this where BDC will be the first triangle and BQP will be the second one. As you can say that where angle Q and angle D are of 90 degree. So here you have BDC. So let me draw this BDC and BQP triangle separately. Like let this triangle be BDC and let this triangle be BQP. Okay, let me write B, D, C and B, Q, P. Now just consider triangle BDC and BQP which has drawn separately. So now here, if you look into this both triangles where angle B became common in both the triangles, where angle B over here became a common angle. As I can say that angle B equals to angle B, I have taken this by common angle. I have taken this by common angles. And next you have angle D and angle Q, where angle D and angle Q are with right angle one. So I can say that where angle Q is at 90 degrees and angle D where at Q it forms 90 degrees and at Q the angle which is there forms 90 degrees. I can say that angle Q equals to angle D because the both angles are with 90 degrees. So you can select by A dot A similarity, I can say that triangle BDC similar to triangle BQP. As I can say that triangle BDC similar to triangle BQP. Okay, let me write this point over here, where first we have proved what? I have proved that the triangle BDC similar to triangle BQP. Done. So let this let this triangle BDC and similar to triangle BQP aside. So let's keep that aside. Now let's go for the second point. So here you have, now consider the second triangle, where triangle ABD. Okay, consider triangle ABD, where, so just consider this triangle ABD. We have triangle, right? ABD, where ABD, where we are here and we are B. Okay, then we have triangle ABD. Okay, next where ABD, where PQ, where PQ is where PQ, the line which is parallel to B, which is the line which is parallel to AB, where PQ equals to Z. So let's just write the value of Z, where PQ equals to Z, AB equal to X, and CD equals to Y, as in the given question they have given. So let me write down like these triangle values. You have two triangles where now consider like in triangle ABD and triangle DQP. Triangle ABD and triangle DQP. So let's say like A over here, A, B, D, and triangle DQP. Done. So if you look over here, where okay. So here you can see that where ADB and DQP, where D became common in both the triangles, where here D is a common angle, and in the second triangle D became a common angle. So I can take like, again we must prove similarity between ABD and the triangle DQP, as where I can say like where angle D equals to angle D by common angle. By common angle. Then next, where angle B and angle Q, where angle B equals to angle Q by 90 degrees. Okay. Angle B equals to angle Q by 90 degrees, where this both angle Q equals to right angle and angle B is a right angle. So right angles consist with 90-degree angle between them. So as I can take like where angle B equals to angle Q by 90 degrees angle. Now here I can say that where triangle ABD is similar to triangle DQP, right? As by A dot A similarity again. Similarity, I can say that triangle ABD similar to triangle DQP. So let me write down like triangle ABD similar to triangle DQP. So we have proven similarity between these two triangles, where BDC similar to DQP and ABD similar to DQP. Now here we are done with this. Now here we know that if two triangles are similar, let me draw like how, where let me draw like two triangles like this, where triangle DQ, let this be ABD PDQ done, and let this be BDC, right? BDC, let this be DC and DQP, let this be BQ. Okay. Now here I have drawn all these four triangles over here. Okay, where BDC, which is similar to triangle BQP, and you have ABD similar to triangle PDQ, where BB are common angles and QD. Okay. Now here I have taken like this. Now here, okay, just take like in triangle. Now consider triangle in triangle. Now consider this one where in triangle BDC similar to triangle BQP or BPQ. Okay, consider this. So we know that if two triangles are similar, then their corresponding sides are equal and their corresponding angles are also equal. Okay, if two triangles are similar, their corresponding sides and their corresponding angles are in the same ratio. As here I can say that where BD by BQ. So here you have BD and BQ, right? So here where I can say that BD equal to BQ, PQ equal to CD and PB equals to BC, where the corresponding sides are equal. So here I would like to take like BD by BQ or BQ by BD. BQ by BD equals to PQ by what? BDC, right? Okay, PQ by DC. So here I would like to take like PQ by DC, where PQ by DC equal. So I would like to take like PQ by DC, where PQ by DC or CD. Okay, done. Now let this be equation number 1 or first equation. Now let me go for the second one, where in triangle, let's consider the second one in triangle ABD. So just take triangle ABD and triangle PDQ. ABD, triangle ABD similar to triangle PQD or PDQ. Let me go with PQD. PQD or P. Okay, here DQP and triangle ABD and triangle DQP, where these both triangles are similar to each other. If two triangles are similar, their corresponding sides are also in equal ratio and their angles are also divided in equal ratio as well. So as I can say, like again, if I take like I would like to take QD by BD. Okay, well QD by BD equal to PQ by AB. So here PQ by AB. As I can say that PQ equals to AB, BD equals to QD, PD equals to AD. So here, so I have taken this because of corresponding sides are equal if triangles are similar. So I would like to take like QD by BD, QD by BD equals to PQ by AB. PQ by A. Let this be equation number 2 or second equation, guys. Or second equation. Now, here we got first equation and second equation. Let me write down over here. Let me rub this one. So we're done with this. Now here we got first equation and second equation. So from adding 1 and 2 equations. So we must add now. We must add 1 and 2 equations. Okay, here let me write down like from adding 1 and 2 equations. From adding 1 and 2 equation. 1 and 2 equation. From adding 1 and 2 equation, we get like BC by BD equal to PD by, okay. So we can like I would like to write like BQ by BD plus QD by BD. QD by BD equals to PQ by CD plus PQ by AB. PQ by CD plus PQ by AB. Done? So I have added. So this is the first equation and second equation, where BQ by BD plus QD by BD equals to PQ by CD plus PQ by AB, as I have taken now. So here BQ plus QD. So here we have what? We have got what? BD become common, as if we take LCM we get like BD as LCM. So let me write like BD LCM numerator by denominator, as we know BQ BQ plus QD. BQ plus QD, right? Equals to, where PQ, numerators we got what? PQ, where PQ became common, so let's take it out, like PQ into 1 by CD plus 1 by AB. Okay, so I can take PQ became common as PQ times 1 by CD plus 1 by AB. Then, now here we got what? BQ plus QD equals to what? BQ, so this is BQ plus QD equals to BD, right? Okay, BQ plus QD equals to BD, as I can select BD. Okay, let me write down the further step over here. So the continuation part over here. Okay, BQ plus QD, guys, gives what? Whole BD, right? So BD by BD equals to PQ over there into 1 by CD plus 1 by AB. 1 by CD plus 1 by AB. Now BD gets cancelled as we get like 1. BD by BD, this gets cancelled and I will get like 1. So 1 equals to PQ value of Z into 1 by CD value over there. What CD value here you have what? Y. So let me write down like CD value as Y plus 1 by AB value over here like X. Okay. Now here with Z, I need this equation, so just here Z is getting multiplied with 1 by Y plus 1 by X. So I would like to transpose this Z to the other side. This becomes what? Z here getting multiplied. If I transpose this to the other side, this becomes divided. So I can say like 1 by Z equals to 1 by Y plus 1 by X. I either can write like 1 by X plus 1 by Y equals to 1 by Z. Done. So what they asked to prove over there, just see, they asked to prove what? 1 by X. So they asked to prove what? 1 by X plus 1 by Y plus 1 by X plus 1 by Y equals to 1 by Z. So hence proved what? 1 by X plus 1 by Y equals to 1 by Z.